So I will start with a little bit of introduction about our company. We are actually CZNIC. We are Czech Global Domain Registry. And I will be gradually explaining how we get to the router business. But we are, in reality, we are some association of companies, but well, we are run as a non-profit. We get money for every domain sold in Czech Republic, so we are using the money to do some good. Mainly spending it on internet and technologies. We do a lot of open source development. For example, we are a maintainer of a bird routing daemon that is covering most of the internet exchange points around the world. And we also, us being DNS registry, we are developing DNS server. Not DNS, it's the fastest one around. And yeah, we do some public education and stuff like that. We are part of the Safer Internet when we are trying to educate kids about safer usage of the internet. But one of the projects that we took over as well is running Czech National CSIRT team. And that's actually how our project started. This CSIRT team, our colleagues, had this big question. We've got a bunch of ISPs that have plenty of public IPv4s for some reason. And they are giving it away to people in their households. And is it safe? Is somebody attacking them? They are not advertising their IPs anywhere. They don't have DNS names for them most of the time. They are not running public web servers. They are not running ads to get traffic to their homes. So are there still interesting targets? Is anybody trying to attack them? How much? How often? And what they are trying to do. Is it safe to have a public IP address? So we decided to start with a project, and we decided to make a security probe. The probe that we will give people, and they will install it at their home. Those potentially non-technical people, we give it for free, and we collect data about who's trying to attack them. And yeah, we started thinking about this project more, and we came up with some conclusions like, well, if we want to get information about the attackers on the public IPs in the households, people will still want to use internet, so this probe has to be able to pass the internet down, so we have to do some NAT there, network address translation. And we need to somehow convince people to run it for us. So it would be nice if it had some fancy added features that would make them willing to participate in this project. So we decided not to make it just a simple probe, but make it into a full-fledged router. And that's how our project was born. We gave it away for free in Czech Republic. That's the blue box, so that's our first router. It has a Wi-Fi in PCI Express slot because it was more convenient for us. It contains some early version of our security research project. And it monitored the traffic that was going through and reported some information. One of the first things that we did was deploying some kind of honeypots to try to see what's going on. But we also collected firewall logs from the outside, so we knew what people were scanning for, and so we could try to figure out what other honeypots do we need to develop. Back then we also collected some anonymized netflow data, so we were trying to learn some suspicious activities and try to detect it and warn people. We were not very successful with that because usually to make it successful you need a context, and as it was anonymized, we didn't have the context. And when we were collecting all this data, we said that, well, hey, we will improve the security of those people since they are helping us. So we created some centrally controlled blacklist, and we distributed it to those routers. So when from the data we learned that there are some attackers, we blocked them. And hardware-wise, it was really kind of nice device for this project started something like 11 years ago. So back then it was quite decent hardware. Dual core, 1.2 gigahertz, 2 gigs of RAM, and 250 megs of storage. For a router, it's quite a lot. For consumer level router. And since we were doing the router, so how did we do that? So as I said, the hardware was pretty decent because upfront we didn't know what we will need. So we made sure that we have enough resources to run whatever we needed. We made a process to automatically update those devices, and we made it a mandatory part of the device, so people wouldn't have to actually administer their device and actually maintain it. They wouldn't need to check for the updates and keep up in the loop. They would just install it, set it up, and it will take care of itself. And we needed to develop the security research program, so we needed to change it all the time and pretty quickly. And we didn't want it to take into account some API stability and stuff like that, because it was research project, so we needed to move fast. One thing that we are DNS companies, we make sure that those routers supported DNSSEC and enable it by default. And since we were giving people the device and asking them to let us spy on them, we said, hey, we are making it fully open source. You have a root account. You can check what data we are collecting, and you can verify that we are not lying and we are spying only on the stuff that we said that we will, and we are not trying to do anything sneaky. And over the time, we developed some extra features. So, as I said, we were trying to be open and transparent. What are the benefits of being open source, even with the cherry on top? Well, in general, as we just heard, there is no way to go fully closed source nowadays. And if you try it, it will just, it's shooting yourself in the foot. If we are developing on building on top of open source, it's really easy to get started. There is plenty of software that is ready to integrate. And one of the questions that we had was how do you make it more user-friendly? That's actually part of what we do. We pick up the great projects that we think are really interesting and awesome, but just difficult to use, and you just put this little bit on top and make it easier for end users to use the technology behind. You figure out your use case and focus on that one and make that one really simple and ignore the 99% that your users are not interested in. And it makes your life easier, your users' life easier, and everybody will benefit. That's what being open brings us. People can contribute and fix their issues. That's really great. And they can do whatever they can, which depends on their technical skills. But usually they sooner found a limit in their technical skills than in what is possible. So that's great for them. There are some downsides. There is plenty of software that could be integrated, and people want everything. So if there is a text editor that two people in the world use this, one is the author and other is some random guy somewhere that found it and started using it, he will try to persuade you to include it and would complain that it's not included because, yeah, in my favorite distribution it does include it. Yeah, so that's kind of downside. You can include everything, but you have to somehow prioritize, and they has only a limited amount of hours. But actually, at the end of the day, some of those people will actually contribute back, and they will package their favorite software and help you maintain it in the end, so you can grow together. Another point that I mentioned previously is people can do whatever they want, and they will. That's the downside. They will figure out really creative ways how to break stuff. And yeah, they will complain that it doesn't work. And when you go with them to some questions, you figure out what they did and how they did it, and you wouldn't believe how creative they were in shooting themselves. So that's the downside. Sometimes it has different consequences. As I said, we are trying to push the updates, and sometimes people make it actually kind of work in a way that it will break after the first update because we override the binaries that they patched manually and stuff like that. So yeah, giving people freedom is difficult, but I think it's a good thing to do. And yeah, depending on open source, you are not really in control of the environment that you are building on top, because the projects that you are depending on are moving forward. Everything is moving crazy fast compared to closed source SDKs. And there is only one solution how to stay on top, and that's being part of these communities and contribute back. And if your views differ too much, there is always a fork option. But usually if there's really some big struggle, then there will be more options, and there will be in the end 2 projects that will go in different paths. So that's how we made the first router, and in the end we actually started making the devices not as a security probes anymore, but we created a device that was actually sold in retail. It was 8 years ago. And the reasoning behind was the probes were really popular in Czech Republic, and they were popular because of the openness and what people could do with that, especially in technical community. People installed various software on top of it, made them into their home servers and stuff like that. And our CSET colleagues were going around the world and telling people, hey, we found this botnet because of this probe network that we have. And they told how this project works, and people were, ooh, I want something like that at home, I want to play with that. So we decided to try to create a commercial project out of it. We ran an Indiegogo campaign, crowdfunding, and it was very successful. And we actually created a device that can be bought in retail. And we are in retail since then. And one interesting point that I wanted to talk about a little bit is that we actually got some business customers. And what's what value do they see in this device? Well, quite often we have some main insight already, because those routers are really popular with geeks. So whenever the company is doing some project, sometimes there is some geeky guy that has our router. Actually, one of our biggest customers, we got them because they were doing some research and they were thinking about the project. And this guy just brought his router from home to work, and they played with it for a week, and they decided, hey, it looks fun. Let's use it as a base. So interesting part is that we have good enough hardware, but actually being open source is our big advantage, and that we push everything to vanilla kernel, vanilla boot, and stuff like that. It means that you don't need any SDK that is usually under NDA. So if you want to figure out whether it is the right fit for your project in the company, you don't have to go to lawyers and managers and stuff like that. You just need to get your manager to sign on buying 2 of these devices on Amazon, and you can start playing with it, and you can develop some proof of concept really fast without involving half a company for 2 months running around and signing papers before you can actually try whether it fits your project. That's one of our biggest assets. Now, back to the security research project that I mentioned in the beginning, and the whole reason why we are here. Nowadays, it's called Free Sentinel. Since we entered retail, it's completely opt-in because, it's spying on you, so it's a privacy violation, so you have to agree on that. But if you do, we install some minimal honeypots for several protocols: HTTP, Telnet, SMTP, and FTP. Those honeypots just emulate the login. So we just ask potential attackers for their credentials, and we collect the credentials, we collect the IP address, and we tell them to try again and give us different set of credentials that they like to use. We have a SSH honeypot that's a little bit trickier. Basically, on the router we run some man-in-the-middle proxy that opens up SSH ports, but the honeypot is not running on the router itself. It's running on our servers, and we are just forwarding the attacker from the router to our data center where the honeypot is running. We are still collecting firewall logs, and we have a dynamic firewall. Basically, all the information that we get from this infrastructure is in real time being sent to our servers, and whenever we decide that somebody is bad enough, we block him right away and send the information back to our routers. So all our routers protect all our other routers, and everybody is more secure. And I will mention it later on, but there is a link, view.sentinel.tourist.cz, where you can see some statistics. But I will mention some statistics as well. Most of the data that we collect is on SMTP. That's the most popular honeypot. Afterwards is surprisingly Telnet. And FTP is not very popular, but HTTP is also not as popular as Telnet and SMTP, based on the data that we collected from our routers. I also have statistics about origins of the attacks. Those are statistics about attackers that we found, so malicious IPs from the last year. And Czech Republic is 35th Sweden is better, you are 20th. But if you look at the statistics, basically you see that the leading countries, India, China, United States, those are all big countries with plenty of people. And yeah, I have a colleague that deals with the statistics, and he said that you never put absolute numbers in a map. You should make it relative. So we take a statistic about the number of people that are connected to the internet in each country and made those data relative. And it helped Czech Republic a little bit, but it helps Sweden much more. So you are in top 10 now. I also have another fun statistic. Last year we started collecting again data about attacks on IPv6. We made sure that our honeypots run on IPv6 if our customers have public IPv6. One third of our customers have IPv6, so based on the logs from our web server when they are trying to do updates. And but actually the attackers, we got 1 million unique attackers in 1.5 million of unique attackers in first quarter of this year, but actually 0.06% of those were from IPv6. So attackers are attacking still mainly on IPv4. So if you want to be secure, don't use IPv4, use IPv6. And fun fact from Czech Republic, we already have an end of life for IPv4 set. It's 6th of June, I think. Yeah, 2032. And that was set by our government because last year they announced publicly that on this day they will stop supporting IPv4 on their infrastructure and it would be able to connect to any of the government websites over the IPv4 and it will be IPv6 only. We will see how it will play out when the time comes. There are elections this autumn that hopefully it will scare somebody and people will start moving to IPv6. So, if you want to take a look at the statistics, maybe if you will have some time at the end, I can show you. There is actually even live view of the dynamic firewall, so you can see the events that are being sent by our routers and see how we are adding bad guys on the list and stuff like that. So now let's go a little bit to the software side of what we do. We are running our own OS on top of our router. It's called Tourist OS. It's based on OpenWRT. We are trying to stay very close to the upstream there. With some distinctions, like OpenWRT is optimized for this small hardware with limited resources. So everything is optimized for size, not speed. We can afford to do it the other way around, optimize for speed and not size. We choose OpenWRT because it has nice extra functionality for the routers. What we did is that we made a much simpler web user interface to make it easier to use by common people. OpenWRT has a great user interface called Lucy, but it's quite technical. So you need to be a little bit skilled and know a little bit about networks to set it up. We have some first-run wizard that will guide you to the initial setup of your router, and we are exposing just the necessary bit to get you working. We also integrate more advanced functionality in a user-friendly way to again, make it more accessible to average people. We also update the device differently because we can afford to do it on per package basis, and we are still keeping the automatic updates inside because we think that it's really important to be up to date from the security perspective. And if we would depend on people to actually remember that they should update their devices, they will definitely forget. So some interesting bits that we are using. ButterFS. It used to be the coolest file system around back when we started. Nowadays there is a BKFS running around that tries to be the coolest one. We haven't switched yet. But why we choose ButterFS is because it supports snapshots. And we use them really heavily. We do automatic snapshot before every update. We do snapshot after the update. So if something breaks during the update, you are able to roll back. We do snapshots once a week. So if you start tinkering with your device and break your network setup, it's easy to get back to the last working state. And you can have multiple of those, whole history. We have a web user interface that you can see on the screenshot. And if web user interface doesn't work, if you break that one, there is a hyper button on the back of the router that you can use to actually do rollback to the previous snapshots. And you can go snapshot by snapshot till it gets to the factory state. Another interesting part of ButterFS is that it supports RAID. And you don't have to have drives of the same size. And you don't actually have to match them and pair them like you would do in classic RAID scenario. So you can put 3 drives of different sizes in your device and make RAID 1 on top of those, and it will work. It will make sure that your data is always on 2 of those. So it's easier for end user to understand, and we actually made a web UI to format those external drives and mount them into the router so you can have some storage inside. One nice example of where the integration bits can really bring some value to the end customer is OpenVPN. OpenVPN is great in that regard that all the configuration and all the tricky stuff is happening on the server. And on the client, if done properly, you just need a configuration file. You can embed all the certificates inside, and the end user just takes the file, double-click it, or whatever, and it will connect into VPN. The tricky part is the server, setting it up correctly, maintaining your CA with all the certificates, all that OpenSSL mumbo jumbo. That's tricky. And whenever I was able to do it manually, but because you do it once a year when your certificate expires, you forget it, then you spend half a day learning how to do it again. So it's not really easy, and probably not something that those people that you met on the streets would do. So we made sure that with few clicks you can create certification authority and create a new client. And creating a new client will actually underneath generate a certificate pair for that, generate a configuration file, and do everything. And you will get just the file that you can put on your device and get connected take home if you have public IPv4. One thing that we really wanted to do, as I said, we have OpenVPN. and we have a way to manage hard drives, including RAID. So one obvious follow-up was integrate Nextcloud, because if you are using Nextcloud, you want to have your data stored somewhere secure, and what's more secure than your living room. And as I said, we have management of the drives. We have VPN support, so you can connect there from anywhere. So yeah, it's again, what we did was we took Nextcloud as it is, we took MariaDB as it is, and wrap it up with some simple installation procedures. So with a few clicks, you can have it installed on the device and start using it. Since we are a router device, another interesting software that we packaged was LibreSpeed. That's network bandwidth measurements tool. And it's again open source, and it actually has a community of servers that you can measure your connectivity against. We are running one of them in Prague, but there are more of those around the world. I was trying to figure out the closest one to here. I thought that it might be either Helsinki or Amsterdam. But there are servers in New York, Las Vegas, Tokyo. So whenever you are, there are some servers nearby that you can try to run your test against. And if you want, it's really easy to set up another server. So if you have a spare server lying in data center and plenty of connectivity and don't know what to do with it, you can continue. Another software that we did, I'm coming back to the security side of the things. We developed something that we call Backcoin. Basically, it's network monitoring. And again, we are depending on a lot of open source bits, and our stuff is just the cherry on top. Basically, currently it's overkill, but we are using Suricata, which is IDS solution, to help us with the packet inspection. Basically, network monitoring is monitoring your traffic going through your router. But in the end, you would get IP addresses and ports and data and length of the connection. Those information we can get easily from contract, and we actually use that. And but most of the connections are encrypted anyway. So the only interesting part is before the encrypted connection starts. So usually we can get information about DNS queries and DNS answers. So we can assign the server name to those IP addresses. And when TLS handshake happens, there is usually also some server name presented. So we store those, and we monitor just a few megs of every connection with Suricata to get those information. And yeah, we display it in the web user interface for people to check what's going on. As I said in the beginning, we tried to analyze some net flows automatically, but it's turned out that it's hard to do without the context, and the only people that have the context are people running the network. So we made this tool to provide them with the data and let them decide whether it is okay or not, whether it is their computer that spent 100 gigs on the YouTube last night and it's okay, or whether it was their fridge that sent 100 gigs of data to China and it's not okay. So that's up to the people to decide, and all the data are stored locally on the device because we don't want it for privacy reasons. Another thing is Moche. By the way, those are Czech words. Moche means guinea pig. but we found some English words to make sure that it looks like acronym. And this is also, again, just a few scripts around foss-north. It's another IDS solution. We just modified it a little bit to modify some plugins to foss-north to provide us with a little bit more of the information that we needed, like MAC addresses to be able to identify the devices in the local network. And foss-north has a really nice feature that you can write your own processing module in Lua. So we wrote a Lua module for foss-north that is collecting all the data about the triggered rules, aggregating it, and sending it to our notification system, so people will get a notification when something gets triggered. We wrote some init script around it that will automatically download some open source rule set. And again, running IDS is something that anybody can do. The foss-north is open source, there are open source rules, and you just need to put it together somehow and run it. And there's plenty of options that you could choose and select. And what we did was just make a nice package out of it and give it to people so they can play with it. In general, this is the security stuff that we have there. We have a Sentinel that is collecting data from the outside and constructing the dynamic firewall and making sure that nobody can get in. But at the same time, we are monitoring all the traffic that goes out and present people with some report of what's been going on in their network. And we can run some IDS to detect some potentially malicious traffic. Last of the slides are future of our project. We are currently in the process of releasing a new hardware that will be available later this year. It will be 4-core, 2.2 gigahertz, and it will have 10 gigabit ports. Two of those for 2.5 gig. Unfortunately, only 2 gigs of RAM. It's a limitation of the SoC that we picked, and it's coming this fall. And it will be below $500 US. And US dollars is falling. So that's good news. Actually, we are buying most of the stuff that we need to make these devices in US dollars. That's why we always set up the price in US dollars as well. So that's what I wanted to talk about. I have a long list of URLs that you can check. We are on Fostodon, so you can follow us. We have some website. What's the most interesting website is viewsentinel.tourist.cz, where you can see the statistics and the attacks, and you can, for example, check your password, whether attackers are already using it. It's modeled after Have I Been Pawned, so basically you don't send us your password, you just send us part of the hash of your password, and then we send back all the hashes that we found in our database. But yeah, you can check it and you can see how many times the attackers were actually entering it into our honeypots. And we are running our own GitLab instance in-house, and we have all our sources there. So you can take a look at what we are doing, and if you like anything, just take it, use it, and maybe contribute back at some point. And we also have a newsletter. Thank you, that's all. We can do some questions, or I can show you the statistics on the big screen. That might be. Yeah. Okay. This way. Yeah, I'm using Chrome, but the reason why I'm using Chrome is not because of the compatibility, but because I don't use it for anything else than presentation. So it's a clean browser without any bookmarks and plugins and stuff like that. This is the website that you come to. You can see the graph of the countries, number of incidents, top countries, and top passwords. We actually have a different statistic as well. For the passwords, we have not only passwords, but also usernames, root, admin, but yeah, you see, FTP. We also have a combination of name and password. Sometimes, as you can see, the bots are not really paying attention what they are being asked to, and just yeah, we ask for username and password, and they give us a get command and user agent. So yeah, they are not reading; they are just writing. Another interesting part is that we have some port statistic that's from the firewall logs. So you can see what the most port scans are going to be. First one is zeroconf, basically. That's not. I think that's not because it's being abused, but because of some misconfiguration in some networks. And if you run zeroconf in your network, it's multicast, and there is a lot of traffic going everywhere. So there is a lot of packets that will hit your firewall. So that's a misconfiguration issue, but I think 137 is Samba. So, and I think this one is some BitTorrent client, if I recall correctly. So then I promised the password checker. As I said, it's not sending the password to us. You can check with the web console. So if I type in some random password, you can see how many times it was used and on which protocols. We actually have an API that is modeled after Have I Been Born as well. And the most fun part is dynamic firewall. Here you can see the feed of events, what's happening in real time, our current block list, and this is updates to the dynamic firewall. Basically, whenever we detect a new attacker, that's the red line there, and whenever they stop attacking, we remove them, and we remove them pretty swiftly as well. It's a completely automatic process. Sometimes we found that yeah, the biggest attackers that we found were active for just a short period of time because somebody noticed them and took them down. So whenever attacker stops attacking, we after a few days we take it out from the list. And we also do gray lists that are daily snapshots of the attacker data. And yeah, if you are a security researcher or something, then you're free to use that one. All these data are under Creative Commons non-commercial by SA. So basically, if you do some security research, we want to be mentioned. And if you want to use it commercially, talk to us and we would like a cut. Okay, I will put the dynamic firewall. Also, we have some nice background, and let's go to the questions. Thank you.
Great stuff. Let's have some questions now. Let's start.
So I have two questions. The first one is related to automatic updates or updates in general. Do you check the environment is what you expect before you update avoid breaking devices? As in, so for example, if a user has their own binary there, then you would inform the user rather than update so you don't break the device. And with respect to the software you put on devices, do you have, for example, can a user reproduce the bit-for-bit same environment that you then install on these devices so they can verify that you haven't added anything else to the system that they can't observe?
Okay, I missed the part of the first question, but the second question is, I know the answer, and it's sadly no. Because, as I said, we are building on top of OpenWRT, and part of the problem of OpenWRT is that it's not very reproducible. Sometimes, depending on the number of core, it also fails or succeeds the build because it's a community run project and it's not that well tested, and there are quite often some corner cases. So yeah, we are not really reproducible, but part of the things that we do as part of our updates, we actually wrote our own update software, is that we are taking a look into all the exported symbols of every package and making sure that whenever exported symbols change, we reinstall all the dependencies so everything matches. And I think the first question was whether we are checking whether we will break the device. It's hard to predict. If you give people root account, they will go crazy and they would break the device in the way that you haven't thought is possible. But that's why we made it possible to roll back to the previous snapshot. And what we do actually is that we detect when they modified some binaries or scripts or stuff that they shouldn't, and we back up their version. So later on, there is a folder with all conflicted binaries that were modified by user between the updates and shouldn't have been, and people can go there and try to find it.
Okay.
Okay, thank you for showing this. How do you tap into these packets in the background? Do you use like Berkeley packet filter, or do you have some sort of kernel patches, or what do you do?
How do we build our distribution based on open?
Oh no, how do you filter these packets, or how do you tap into them?
Oh, packets. Yeah, not packages. This is output from our, there are multiple events. One is Telnet Connect, HTTP, that's our minipods that are running on the device. And other part is firewall logs. I haven't seen it there yet, but yeah, there was one. Now it's gone. But firewall logs, basically, we are using the standard firewall as it is in OpenWRT, but we are inserting a special rule at the end. There are various chains in NF tables, and the default rule is drop, but you can insert the last rule before the drop, and that is lock the packet, and then we are collecting all the locked packets and sending the information about the locked packets We have two types of events that are showing there, small scan and big scan. Basically, small scan is if somebody scans at least 10 ports. Big scan is somebody is scanning more than 100. And those two events contribute to your overall score on our scoreboard and on our evaluation whether we are attacker or not. But firewalks alone would never put you on our blacklist because the source IP could be spoofed. But for the honeypots, if you connected to our fake web server and entered credentials, even though you entered the user agent instead of login, you are kind of malicious. So that will put you on our blacklist. And again, it wouldn't, just from one router, we wouldn't put you on the blacklist. You have to be a larger scale attacker because, yeah, one router can be bought by malicious third party and try to spoof the data for us.
Sorry, we went out for 5 minutes. Maybe that question was asked. Are you running like database honeypots as part of your setup?
Whether we are running some databases on the router on the server.
Because of all the distribution, you said you're surprised you're seeing SMTP traffic as being the top, being like trying to exploit, but like I was surprised to see like not open database ports there or something.
Yeah, we are not running database honeypots yet, unfortunately, but yeah, if I go here, ports, then those are most abused ports, and I think that database is not in the top list. I'm not sure. Yeah, it might be interesting to run a database honeypot. I've seen awesome talk at FOSDEM about what they did with some database honeypot, and it was great. Yeah, there's only so much time, so we have to figure out what honeypots we want to start with, and we choose those protocols, and yeah, we will, over the time, we hope to develop more. But yeah, as suggestions goes, one of the things that we have on our radar is some RDP, because those seems to be quite abused, but they are also quite complex compared to Telnet or HTTP.
Okay, one last question, and then I think we'll end, since we're running out of time.
So how do you manage support for your hardware? So if you let everybody in on root, you probably have much more support than the lockdown, but at least what the people tell us that have a lockdown hardware.
We don't have a lockdown hardware. I don't know.
Yeah, but the support, how is it managed today? If someone raised something, do you support it?
Oh, yeah. Support. Well, one of the things is that we support you as long as you are reasonable. Like, yeah, we have a community forum, so if you ask us a really tricky question about your setup, we might answer, but we might also tell you, figure it out yourself and go to forum and try to ask other community members. We generally support when you are in trouble regarding our software that we provide, or in general. There are some limits to the support. We actually have a Phillips screws on the case, and we even support you to open up the hardware. But where we draw a line, if you start soldering on the board, then that's not covered. And actually one of the other, really from the root perspective point of view, where we draw a line was destroyed EMMC. Because we found some people that were putting something like influx on their router and storing metrics from the IoT every 5 seconds, and they actually managed to go through the lifetime of the eMMC. But luckily for them, our router has various cards in mini PCI Express slots, and one of those slots is NSATA as well, so they can buy SSD, put it inside, and boot from SSD and continue using their router with SSD inside.
Excellent. Thank you so much, Michael.
Yeah, if you have any more questions, I'm here today and tomorrow. Just grab me somewhere and let's talk. Thank you.